Hi, I'm Raleigh Astronomy Club co-chair and JPL Solar System Ambassador Doug Lively, and welcome to Moon Zoom. Tonight's presentation will concentrate on all things lunar. Tonight, we'll review some aspects of lunar geology, probe lunar landing sites, discuss one theory on how the moon was formed, and explore the moon in real time through a telescope. We join Moon Zoom, already in progress. I was going to kind of point out some of my favorite areas on the moon. This area right here that's marked by an X. How many of you guys know what that is? Right there in the center. That's Pallas Putridinus. It's my favorite lunar name. It means the marsh of stink, or the marsh of rot. So, one of my favorites. This is the Mons Alpins range, and this is Mons Caucasus. This is Mons Imbrium, the Mare Imbrium, this black area right here. Like I said, it's one of my favorites. I think it was Apollo 15 that landed right in this area right here, right around in this little area right here. Oh no, I'm sorry, I'll take it back. It was right here, that area right there, right in that little niche right there. And let me drop that gain now. I need to drop the gain. It's kind of blasting out the left side of the moon here. The gain's pretty low now. Maybe I'll drop the exposure. There we go. A little too much. Whoops. There we go. So that's one of my favorites. This is Mare Imbrium is really one of the coolest mare to me. I mean, it's a place where there was a lot of it was formed during the heavy bombardment about 4.3 billion years ago, and a lot of really cool and interesting things in Mare Imbrium. Just one moment here. Hey, has anybody got anything that they're showing real time? All right, hold on a second. Let me just so since we kind of go ahead. All right, so since I've got a few things to talk about here. Give me another second here. Whatever that is. There we go. So for those of you, because I know we have some folks that are new to the club and everything. So basically, kind of lunar theory about how the moon formed was that there was basically another, basically a Mars-sized planet. For lack of a better name, it's been named Theia, and supposedly it was competing for the orbit for Earth's orbit. And it lost. And so this is kind of an interesting video here. Let me just play this here for you guys. So this is basically Theia.
I think the moon formed when the Earth was struck by a very large object as the Earth was forming. So this would have been a similarly formed planet that was vying for dominance in the inner solar system with the Earth and other growing planets. But it collided with the Earth and ultimately was absorbed by the Earth and
Can you guys see that?
So in
Yep,
terms
coming through great.
Can you hear it?
We think
Yeah,
Oh, super.
it's fine.
planet Mars, or it collide with the Earth in the core, silicate mantle, like the Earth, and it would have had 10% of the mass. We think initially the inner solar system had maybe 20 small planets, and it was through collisions between these planets that we eventually ended up with our final 4 terrestrial planets. Now, the last of these big collisions on the Earth was the one we think formed the Moon. The reason that we focus on a Mars-sized impact is that that is the impactor size, that if you hit the Earth with a Mars-sized impactor at an off-center angle at the expected speed, you will start the Earth spinning with about a 5-hour day. It's a very rapid spin rate. But it turns out that is what is needed to agree with our current 24-hour with the Moon at its current distance. The Moon is moving away from the Earth. So we know when the Moon first formed, it was much closer to the Earth, and the Earth was spinning much faster. So the idea.
So I found that pretty interesting, you know, in the sense that, you know, that really to kind of get to, you know, a 24-hour spin, to really get the Earth spinning and everything at a rate that would actually be conducive to the formation of life, you really had to. It had to somehow. You had to get it going somehow, and kind of the calculation that that if you heard her, she was saying, well, hey, we need to have something that was roughly, you know, 10% the size of the Earth, or about the size of Mars, you know, hit the Earth at an oblique angle to kind of start that spinning, and then the rest of that material kind of spun off to form the Moon. And then I guess eventually over time, as the Earth, again, had a rotation of about 5 hours, you know, it slowed down, the Moon moved further out, and we kind of got that 24-hour day that we've got going on now. All right, and then here's another cool little video that I've got that kind of talks about period of late bombardment. It's I think it was kind of a cool one. Just give me 1 minute to pick it up here. Oh yeah, this one's. Oh, wrong one. So this would have been after the Moon had formed and was beginning to cool, and it had a fairly solid surface and fairly bland, somewhat featureless surface, until we reached this period called the late bombardment, about 4.3 billion years ago. And we had some incredibly large impacts that occurred, mainly through asteroid, and then later through volcanism on the Moon itself. So you see how those dark areas are really turned out to be basaltic flow, basically from magma and everything that was actually coming up from the Moon and kind of filling out those low level land, or those low level areas on the Moon. Also, kind of a benefit is that the moon really kind of took it on the chin for the Earth. And so now we kind of wound up with today's moon like that in that format there. And so that's actually what we're looking at right now is this area of Mare Imbrium. And let me just make that adjustment just a little bit. It's kind of drifted out on the scope. And I'm going to bring this image up to 100% here. Let me just adjust that focus just a tad. I just hit the tripod leg, so now I have to wait for it to settle. Scope's super sensitive. If I just bump it just a little bit, it just really wobbles a bit.
Does SharpCap tend to exaggerate the shaking because it draws out the accumulated data over time?
That's a good question. I could have an adjustment that could maybe make that faster. I'm not as familiar with SharpCap myself, so maybe if I could drop that. Let's see, maybe I could drop or up the frame rate a bit. What do you guys think? Speed traffic's pretty high. I am going to move that. Let me move that image over. I just want to. right. And let me up that exposure just a little bit more. All right, I do have it a bit overexposed, but it's because I really want to kind of bring out this cool little feature right here. It's called Sinus Iridium. Part of it's in shadow right now, so I'm going to boot it up. I'm going to bring it up just a little bit more so we can see it. Oh yeah. All right. So it's kind of one of the cool things is that I'm gonna pop this down just a little bit more here, and then we'll see. Okay, so what I was talking about during that period of heavy bombardment, you really had, you had this really interesting that you had this mountain range here. This if you notice right here, it's pretty flat. There's like a little gap here. This is called the Alpen Gap, and it's really kind of cool because basically you had magma from that was still not cooled. In the moon, it was still hot, really quite, and when you had that heavy bombardment, it just literally broke open these basins that were filled with magma, and literally overwashed these mountains, creating this gap right here. So it's kind of a really cool thing. And then the other thing I thought was really interesting is this, and I'm going to overexpose the picture a bit. So we had these semicircular structures like this. Okay, so this is Sinus Iridium, and what's really neat is that this was probably formed as a crater prior to or during, maybe early on in the heavy bombardment, but the magma kind of overflowed that area and literally caused this area to fill up, creating this semicircular structure that we call a sinus. Yeah. Clear that. You guys have any comments about that?
No, I think it's really cool.
Yeah, it's and it's not the only sinus on the. It's kind of funny as it's the same word as your sinuses, which actually happen to be semicircular sacs in your nose that can actually fill up with goop when you get a cold. But there are other sinuses on the lunar surface, and I just thought it was kind of cool to kind of bring that out. This little crater right here, this really nice dark one, is known as Crater Plato. It's just the name of it. So that's a neat one. That's a neat one. I don't know if you guys can see it. I guess give me one moment.
If you can see it, we can see it. We got a perfect picture here.
Oh, good. Thanks.
We ought to do this. We ought to do this every week.
Oh, wait.
This is coming from your telescope?
Yeah, right on.
That is absolutely amazing.
Prime focus, yeah.
We can all go out into big woods and sit in our cars on our iPads.
Yeah, the internet wouldn't work so good out there.
My lunar.
Somebody's got a mic and you.
Not me. Someone needs to like mute their mic or something.
Ronnie? Yep.
Is that better?
Okay, Doug, as you were saying.
Yeah, as I was saying. Anytime you see one of those semicircular patches like that in the moon, on the moon, that's probably a place where the it was a low-lying area. There may have been more than likely there was a pre-existing crater there, and then the mare that's near it was smacked with an asteroid, kind of broke that open, and that overwash of magma just like filled up the lower end of it, like you could see on that one that I was just showing you. So, but yeah, that was a pretty cool one. Just show you another one here that's kind of cool. Okay, so for whatever reason, this is actually not a named structure. If you look right here, let me blow this up to like about 100, like about 75%. If you look right there, there's like a rip through that mountain range right there. It's just a straight line rip through the whole thing. So something came through there and just.
So he's drawing on the screen and everything.
Oh, that's interesting.
Well, right now he's not.
Yeah. Well, here, I'll show it to you.
Things.
What I'm pointing out is this area right here. This guy right here.
Just lost it. There's no internet up here very well.
You see this rift right there? It's like, what caused that? I mean, something went in there and just.
Not ready for prime time.
Come again? Like I said, it's not a named structure, but yeah. Let's see, down here, this little guy right here. This is Mons Peyten, just this lonely little mountain sitting out there, and Mons Peyten is about 20 kilometers tall, but just sitting out there in the middle of this lava plain. Again, it was probably a mountain that was already on the lunar surface, but during that period of heavy bombardment, it just overwashed it, almost overwashed it, Let me clean this up a little bit. And I'm going to drop the zoom level on this guy. And let's see if we can show something else. All right, let me just adjust that image up a little bit on the scope. out that way.
That's really amazing. The software and your telescope.
Thanks.
Yeah, I was just thinking the same thing.
Have you talked about Apollo landing sites yet?
I talked about one, which was Apollo 15. Before I get off of it, I'll point it out again. So, so this is Palus Putridinus right here. This area right here. Again, Palus Putridinus, the marsh of rot, marsh of stink, and then the. I'm going to clear the annotation really quick though because I need to. It's like in the way of my. And then what happened is that Apollo 15 kind of came into this little area right here. And I mean, I just can imagine how cool that must have been because you had the lunar lander come right in here and sit kind of nestled with these mountains right behind it, these huge, majestic mountains. And then they were basically, and then they were the ones tooling around on the lunar cart there. But that little area right there is where Apollo 15 landed.
Thanks. That's really cool. I like that.
Clear that off.
That camera's working really well for you, Doug.
Oh yeah, I'm loving it. I'm loving the detail that you're getting out of really kind of these really dark areas. I mean, it's gotten darker, but when we first started, this area right here actually was showing some brown in it right here in Palus Putridinus, which was really pretty cool. But
now you're not stacking the images though, right?
No, not live. I'm not live stacking or anything. This is just raw coming right off the camera.
I wonder if you live stack the moon, if you'd get any color out of some of that stuff.
Do you think it would stack because usually you have to have some stars to stack on? Well, let's give it a try here. Let me give.
Oh yeah, right.
Doug, you won't be able to stack.
Yeah, it won't live stack. I'm pretty sure. I'll probably get a message saying no stars. It'll start throwing away.
Yep. It'll take one, and then everything else will get thrown away.
Right.
Although if you unchecked align frames, it might allow you to stack. There you go.
Yeah, but with the moon moving, it's just going to blur out.
Yeah, Let's turn off live stacking. Hey, Mike, do you recall what the camera flip is? Where that's at?
Sorry, say that again.
Where the camera flip, where you can actually flip the left and right of the camera, frame flip.
I believe that it is. If you go under, do you see where it says FX none up top?
That's where we were there. But I don't.
I looked it up on the simulator, and it was under the USB settings under the camera controls, but who knows?
but I don't.
Yeah, unfortunately, we lost power and internet in Apex. So.
Oh, really?
Yeah.
See,
I had to take the drone up.
Oh.
I had to take the drone up to see how far it went. Mine, it's pretty widespread through my.
Oh, really?
Okay, Barton says it's shown somewhere. I think he just posted a comment.
Oh, did he? Oh, maybe.
Yeah.
Oh, what did I do with my chat? Oh, there we go.
It's under camera controls, but your version appears to be different.
I'm running 3.2.
Well, it all depends on the camera. It changes things for each of the cameras.
Oh.
What if you go under options?
Didn't see it there either. Just says full screen or reset control order.
Hey, Mike, I noticed he has enable live broadcast on. I'm not sure what that does.
Where do you see that?
Under his camera controls, under DDR buffer.
Oh. Oh, I've never seen that.
We're also running this in preview and not capture. I don't know if that makes a difference.
Yeah, that won't make a difference.
Okay.
Because that'll just like record. I mean, basically that's more video but
yeah. Doesn't hurt to record some.
It could be just the capability the camera has to surface that it doesn't surface in this driver version.
Hey, Doug, can you go to full screen on that window and give us a bigger picture?
Yeah, sure.
That feels good. Thanks.
It's probably just something the driver doesn't expose.
Well, I could probably go to 100% there, but it's a little blurry at 100%. So that's why I'm popping it back down to 50 to get a better.
Yeah, I don't believe the landers are up there anyway.
Hey, in that view, can you show us again where some of the landers are? This is cool.
Yeah. So again, this would be where turn the annotator on. There's Apollo 15 right there. That's where that one went. That's why I was trying to actually flip it because my perspective's a little over with. Let's see. Okay, so this would be over here is Mare Serenitatis, and this area right here is Mare Serenitatis right here. And so let's see. That would be the last one, and Mare Serenitatis would have been Apollo 17, and let's see, it was, give me just a minute. Again, I'm trying to flip myself around. I think it was, wait, if this is Mare Serenitatis. Oh, yeah. And there's Mare Tranquillatus. So it had to have been that's what's blowing my mind. I think it's really over on this side right here. It would have been right in here. Yeah. It was actually right in this area right here. So Apollo 17 would have been right in this area right here. So that's where Apollo 17 would have gone. And for the others, I've got to go down and left. So give me just a minute.
Well, I guess the question is, where's Apollo 11?
Yeah, I'll show that to you. It's down. It's down. All right, just give me just one moment to catch my bearings here. So this is Mare Tranquillatus, and at the very bottom of Mare Tranquillatus, there's this little sinus called Sinus Iridium. And let's see here. It's hard to see these craters here, but they named these craters right after the Collins, Armstrong, and Aldrin. And right in this area, I kind of drawn where latitude 0 is on the moon roughly, and right in this area right here, you see this little dip down like this. This would be about the place right here where Apollo 11 landed. Actually, wait, this is really the reason why I have this thing flipped. I wanted to go back to the flip. It's actually over here. It's on this side, right here. Apologies.
Sorry, so you got the flip to work?
No, I haven't. That's why.
Okay.
That's why I'm sitting here looking. It's going. Wait a minute. No, that's not right.
It's hard to tell if the thing is reversed from what you're used to.
Yes, it's reversed from what I'm used to seeing, and so that's why I'm. Yeah, it's right in this area, right in here. Is where it landed. So, sorry, I'm trying to clear this up. It's, yeah, right around here. Excuse me, just one second here. Just off of Sinus Aspiratus. It was at the very bottom of Mare. Again, this is Mare Tranquillatus right here, the Sea of Tranquility, or the Peaceful Sea, and yeah, right. And then again, this is basically about latitude 0 on the moon, and they were just above latitude 0 right in this particular area here. So that's where 11 would have been.
It's easier to see them when we're near the terminator, and you can see Sabine and Ritter, the big craters. And then you can, a small scope, you can actually see the 3 smaller craters that have their names on them.
Right. Ritter is right up. Let me just clear this off. Let's see. Ritter is. It might be a little bright we might be a little bright for Ritter.
I can't see it.
There's a crater here. And then the one right beside it, which would be this, is probably a Ritter crater right there. And there's another one just off from it called Sabine. Let me clear that up because it's so anyway, here's a small crater here, another one here, and another one here. This one is Ritter right there. That one is Sabine. And then Apollo 11 is right in this area right there. So let me just adjust that scope down a little bit more, and we'll go for well, Apollo 14. We might as well get Apollo 14 because that's right in that area. So again, here is right at 0 degrees latitude on the moon, and Apollo 14 was just south of it. In let me clear this annotation real quick. I just drew over one of my craters here. Let's see. And I'm going to drop the contrast a tad, or drop the gain a bit, because we're getting a bit too. Maybe I'll boost up. Come on. I'll boost the contrast a little bit and see if we can. Yeah, that's actually better. I need to probably boost that a lot more. And then let's try to get drop that brightness a tad. Oh yeah, great. Oh, that's super. Great. So, again, I'm trying to flip this in my mind.
More?
So Apollo 14.
That's a nice exposure.
Huh?
That is a nice exposure.
Oh, thanks. All right. Apollo 14 was actually up more on a highland area, and it was, let's see, let me just think if we go here, tomorrow, Harry and...
Hey, Mike, mute your mic.
It was right in this area right here. Let me draw that line one more time where latitude 0 is. Here's latitude 0 on the moon. And oh yeah, I actually got to do this in reverse. Oh, that makes much more sense. Let's see. Huh. Oh, that really plays with my.
The Rob is saying he knew the moon landing was fake. There's no stars.
Yeah, the moon has its own light pollution, you know. So it's over here on this side, so it's right above. There are these three. Oh, here we go. Here are these three craters here. Free, Morrow. Looks like Borland and Perry right here. These three guys, and they landed right here above this guy right here. So that's where they were landed. That's Apollo 14.
Hey, Doug.
Yeah?
All right, I just checked. So I played around with the test cameras in SharpCap, and then I just plugged my ZWO. It is camera specific. So The only one that allows me, gives me an option to flip is my ZWO.
Oh, okay. Well, there you go. So, I thought I did it last week, though, but all right.
It's not too late, Doug. Maybe you can get your money back.
Yeah, no, I don't think so. But thanks anyway, Rob. All right. Let's see. Come on, clear. All right. All right. No, I think it's working very well. So, all right. So let's see. Let's try to get. Let's try to get Apollo 12.
It's right next to it.
What's that?
Oh.
So we're at Apollo 12 here. Let's see. Give me just a minute. We're going to go back towards the terminator. All right, this one is not as easy to find, so give me just a minute here, especially now that I'm sorry, just give me. Let's give the image a minute to stabilize. And let's see. There's three guys. Yeah, they're flipped. And there is Harry.
Doug, for us beginners,
What's
how much
that?
equipment or what? For us beginners, what equipment are you actually using to produce this?
Okay, so
Camera,
so the telescope is an LX200 10-inch telescope. There's a Schmidt Cassegrain, and so and I'm using that's the camera is actually directly connected to the back of the scope, so that's it's prime focus. So that's the scope. The camera is a
QHY.
I know it's QHY, but it's a 163.
It's a 163 color, which is exactly the same thing as a 1600 color from Zoe.
Yeah, it's a cooled camera, so it actually has a cooler on it to kind of keep the So when to keep the CCD cool, and that keeps hot pixels from flaring up on the on it. So and it's a color camera, so that's why we're seeing a lot more variation and with browns and stuff.
Yeah, but Doug,
huh?
I think the question from a beginner is, what's it going to take to do something like this? You can do this for under $1,000 with a lesser scope, lesser mount, lesser camera.
I mean, the ZWO 120 is an excellent lunar camera. I mean, it really is. And you can get that for about what, $120, something like that.
The camera you're using right now is designed for deep space objects, nebula, and galaxies. It's way overkill for the moon.
Yeah.
And so is the scope. I mean, it's a luxury to have a 10-inch SCT.
Right.
I've got that little 6-inch SCT that I bought from the estate.
Yeah.
The Nexstar X6SE. Yeah, that with a $200 camera, and that's all you would really need. You could pick those kind of mounts up with the scope used for like $600 to $800, and another $200. So under $1,000, you can do better than decent.
Yeah, I was actually just looking at the Nexstar, brand new at $799. You can get it for $799. So I mean, for a computerized go-to scope, I think it's an excellent buy. The club has got a couple of them in this inventory. Isn't that right, Mike? We've got a couple of Nexstar 6s, right?
No, we have one Nexstar 8.
Oh, we have a Nexstar 8, yeah.
Even better. Yeah, but the point is, what you're doing here with the electronically assisted astronomy, you don't need for the moon, you don't need a German equatorial mount. You don't need a fancy mount.
Right.
And for most EAA, you really don't need an equatorial mount. You can deal with a cheaper alt-az. So you can get into this kind of real-time imaging for easily under $1,000. Now, if you want to go to the deep space, deep galaxies, you're going to spend, most of your money on a stable mount. The moon, you don't need much of a stability in the mount.
Right. I mean, you can see when I just bump this mount just a little bit, how it just. I'm literally if I just brush up against it, it really destabilizes the image. You need, really the Meade field mount is not really the mount. Is not necessarily the mount for astrophotography.
Now you have a sensitivity to wind, right? Because last night you couldn't do it because of the wind.
Yeah, the wind. Well, the wind. Yeah, exactly. So I had looked at the forecast for the wind, and it was supposed to be dying down about 8:30, 9 o'clock. Well, I was out here at 9 o'clock, or really 8:30, and it was still really blowing hard. It was actually supposed to die out at 6. So I knew that there was no way. It was just going to be buffeting the mount all night long. We wouldn't get anything, and so that's why I had to kind of cancel things last night. And I apologize for the last minute, but according to the forecast, it should have ended at 6, and it would have been calm, by 9, and we weren't even close to that.
So, Doug, do you mind if I share? I'm not.
Yeah, absolutely, man. Yeah, sure, please do. Yeah.
Just to that question, I wanted to show an example of what you can do with an iPhone camera and a 4-inch refractor, not even a one that has false color in it. So
sure. Why don't can you grab it, or do I have to give it to you?
Let me see. You have to stop, but then I think I can share. Okay. So
thanks. That'll give me a chance to play with that focus just a tad.
Yeah.
Not really.
So I'm trying to share photos. Okay. So just as an example, here are, I don't know if people can see my screen or my photos.
Yeah.
Is that a yes?
No, I can't see it yet.
No.
We can see you, but we can't see your screen.
No,
yeah, I don't know why it's not. How about now?
There you go.
Got it. Yeah,
okay.
super.
So,
awesome, man.
So this was taken with an iPhone, clamped to an eyepiece through a 4-inch telescope that wasn't even moving. It was completely manual, and just kind of snapshotted it. So I'm hoping I don't know why it's not letting me do other ones. Let me try another one. I'll select multiple. Bear with me here. Okay. So, you can see a bunch of these. Again, some of them were taken when it wasn't optimal time. But this is as simple as you can get. The real issue, and this is one that I was really happy with, closer to the Terminator, and this is just basically snapping a picture with an iPhone. The key is to get the right apparatus to hold the iPhone over the eyepiece and be able to adjust it, so it gives you a really good view. But so this is an example easily of what you can do with even very, very modest equipment. Again, this is the moon. It's a very different story if you're talking about deep sky objects or even planets that you want to take a longer exposure on. So, but this is a really good first step.
Yeah, I've tried the iPhone mount thing. I just couldn't get it quite exactly right, centered over the eyepiece, so I'd stopped. But
so Mike's has these big, gnarly green knobs on it that it's real easy to adjust. And I've got another one. I got a Chinese knockoff. It's nowhere near as cool. You got the Celestron?
Yep, the NEXYZ. And yeah, it basically, once you clamp it on the eyepiece, then you have knobs to turn it in all 3 axes, which makes it so much easier instead of having to have it fixed and then clamp it on. And that's the problem. Every time you try and get it centered, it's just almost, luck of the draw if you don't have those micro controls to get it just right.
Yeah.
What was that, about $50?
Yeah. I mean, it wasn't like horribly expensive. I mean, some of the knockoff cheap ones are $25. Now, the one thing I will say is that, there have been some issues with the quality of these, of Celestrons. I noticed that, some of the rails that they ride on and the shimming wasn't as, kind of as precise as I would have hoped.
It probably matters how heavy the iPhone is too.
It does, and if you had or if you don't have an iPhone, if you have another camera, I would say that some of the phones where the camera's a little kind of not necessarily towards the edge of the phone, but rather maybe recessed in a little bit towards the middle of the body, those would work a whole lot better. So again, this is just a few examples of something. This was actually from an older camera that I just took a snapshot of doing some live viewing with a lower resolution camera. But these other ones were taken with an iPhone. Again, here's another. To me, this one was I can't believe I did this with an iPhone with a mount that wasn't even automated or tracking. I mean, and just got it.
What was the other one? The 385?
No. This one was my.
That one.
Yeah, this one was. No, I can't remember. It's Astro Video Systems. It's a CCD chip. It's got standard resolution, so it's like 640 by 480 pixels. So it wasn't. It's definitely not as high resolution.
Yeah, I think tomorrow I'm going to set up if the skies are clear with my QHY10 is a CCD one-shot color. I want to see how it does on stacking and the moon. I mean, it takes 20 seconds to download an image on that one. It's old school, but it's CCD, so it's really cool.
Yeah, part of me misses the CCD just because it captures so much faster than the CMOS. But at the same time, I think they tended to be lower resolution and larger pixels or By far, the image quality is so much better with my CMOS than with the CCD, but I guess everything comes with its pluses and minuses.
See where Doug is.
He's still here. Y'all keep going.
He's still focusing, and
yeah, I'm focusing. So
yeah, so that's really interesting. I mean, I've tried putting my little DSLR on the back of my small telescope, and it's like tonight, the moon in my backyard was so high up, my camera would not fit on the back. It's just it's the mount.
Yeah.
So looking through the eyepiece would have been better if I had the mount working.
Yeah. Yeah, I have that same issue. I have only a certain amount of clearance between my scope I use the most. So yeah, if I have to have just the right set of spacers. Otherwise, the scope itself won't actually pass through the arms of the fork. It's an SCT.
Yeah, so I got a wedge for the 6SE, and the wedge solves the problem. It creates other problems.
Yeah.
And for the small scopes, it's manageable, but the alignment is still very delicate. When you get something like a CPC 1100, like you have, you need 2 men and a gorilla to mount it on the wedge.
Well, see,
go ahead.
That's not a problem, Paul. You, me, and we can bring around Rob.
Bring Rob
as the
to
third.
put screws to it. Yeah, one of us holds it, the other one.
Yeah,
it gets kind of awkward when you're holding a big scope at an angle.
Yeah, you guys fight it out to figure out who's the gorilla.
I don't know. Rob's been working on this beard for the last couple of weeks. He's looking pretty much the part.
It's all right. My wife made me shave.
You ever buy a basket of strawberries and you leave them in the refrigerator for 2 weeks and you forget about them? That's what Rob's chin looks like.
Well, Doug, I'm very bummed. I was just about ready to be out there with you.
Oh yeah.
And I haven't figured out all my 12-volt issues.
What happened over there in Apex?
Don't know. We heard everything stopped, and we heard a bunch of sirens, and we didn't hear sirens. I sent the drone up to see what was going on, and couldn't find anything other than most of our neighborhood was out of power.
Any funny lights from the Sharon Harris direction?
I figured they shot it down.
Has anyone ever read this book? I just got it, and I'm beginning to read through it, but it's a really, really good source book on the Apollo program.
What book is that?
It's called One Giant Leap by Charles Fishman.
No, I have not.
It's fairly new out, I think. Let's see. I don't know when it came out. I got it for Christmas. I'm just beginning to read it, though. Yeah, it's fairly new out, though.
I gotta sneak in here. Get a book.
Copyright 2019.
Yeah, so one that I had gotten and it really helped. Sorry, who did you say was the author?
Charles Fishman,
Okay.
Fishman.
Yeah, I had gotten this one. It's called Stages to Saturn, and it's one of these reprint books. But it's basically it's more of not necessarily a technical manual, but it's definitely written more along those lines. It's really less about the story of what happened and more about just the design, the project management process of it all. It was it's actually really, really good. I was surprised at how much I learned from it. But definitely not a novel or anything like that. It's a closer to a technical manual.
Yeah, this
or
is more
a
of a
white
history,
paper.
but I
Yeah.
think I would like that one too.
Yeah, I'll have to look that one up.
For one, but I'm just about 1/4 through it. I really like it. Stages to Saturn.
Yep.
And who's the author?
Roger Bilstein, Bilstein.
Okay, thank you.
And you can get it from something called Forgotten Books. It's like a forgottenbooks.com. It's basically it's a reprint, but it's
Great. Okay, thanks. Appreciate that.
yeah, because it looks like it was I think where they actually got it or eventually reprinted this, because it's it's supposed to be a technological, they call it technological history of the Apollo and Saturn launch vehicles. It was actually published by NASA in their NASA history series. So I know you can't buy, it's not in print anymore. So this Forgotten Books group, I think, literally replicated a library book, because you can see where there's a spot in here that says Apache Junction Public Library.
Doug, are you the only person outside? Is Doug the only
Yes, I'm
person?
the only guy, yeah.
Yeah. Well, I checked right before you started, and the scene was really good. And I went back out a second ago, and it's deteriorated quite a bit, at least over here where I am. The scene was surprisingly good about 8 o'clock, 8:30.
Yeah. Yeah, I'm just trying to finish out with some of the positioning on the moon right now.
It's in that book where they talk about the smell that the astronauts could detect when they got back in their lunar module, and the lander smelled like burn. They speak of this in the book.
Yeah, I've heard that too. I can't think what would cause that unless they had an electrical short somewhere.
in those days,
Yeah.
I wouldn't doubt that. I mean, they probably used a lot of their stuff was potted and used bakelite. And I mean, I grew up. My dad was a TV repairman, and I grew up smelling that stuff. You know, and just the way that the electronics were, they used this potting material. It's kind of like tarish, made out of tar, and you could smell it. You know, as the current was going through it.
Well, in the book, it speaks of them having dust on their clothes, and when they came back inside, briefly, when it mixed with oxygen and, you know, gases inside, it had an odor until it.
Oh, really?
Yeah.
Yeah, I was just joking about the electrical being inside the thing. They did. I read that too.
Yeah.
They're probably lucky that dust didn't short the electronics out.
Well, they were afraid that it would react similar to gunpowder or something, because it never had any reaction with oxygen and other gases like that.
Yeah. Well, that's a good problem. That's a possibility. By the way, one of the interesting things that they discovered by looking at the rocks on the moon and everything is that the rocks on the moon are composed of the exact same structure as that that we have on Earth, except that they're drier. And what that told them is that it's most likely that the moon itself was formed in intense heat. Kind of giving credence to that impact theory that we were sharing a little bit earlier. So, but that's interesting though that they actually noticed a smell of, you know, on Apollo, I guess it was Apollo 17, is where they actually, you know, saw atmosphere coming up over the horizon, and you know, they were the astronauts were kind of laughed off about that until I guess it was LRO went back and actually discovered that there was a rarefied atmosphere on the moon. So the moon is capable of keeping an atmosphere, but it's rarefied. You know, it's really super rarefied. I'll go back and share my screen now. We're kind of looking at that lower limb, and I believe this is, give me just one moment here. This is that bright patch right there is Tycho.
What's that bright patch in the lower left?
Yeah, that's Tycho.
Could I try to share the screen and show you something in Tycho?
Yeah, sure. Oh, yeah, sure. Are you going to show us the boulder on top of the peak?
Yeah, my favorite thing.
Oh, yeah, that's really cool.
I don't know if I can, how to do that. If I hit share, would that do it?
Yeah.
Okay, I'm not sure how to make that happen. Can you see it?
Yep. There you go. Now that's so cool.
Upper left corner is Tycho, and there's a little mountain, and then this larger one, if you can see where I'm pointing. I don't know if you can. And then down right there at the very little saddle place, there's this big old white boulder. Doesn't really make any sense. When the mountain rebounded, I guess it came up and it just fell back in place.
Yeah, it's just sitting right there at the top of that peak.
Yeah. Yeah, I was trying to see it tonight. I think you need about a 60-inch telescope to do it. I always take a look just in case.
Oh, yeah.
So, Jim, what we're looking at, that mountainous cropping, that's just, if you look in the top corner, that's just that center peak area. That entire main picture is just in the middle. It's not. We're not looking at.
Yeah. This is just this little tiny spot.
Yeah.
Can you see my pointer? I don't know if you can. That's just right there, and it's almost like a little U-shaped saddle. And down in here, this almost looks like a caterpillar blade. Something pushed it in there.
Yeah.
aliens, I guess. Well, now I don't know how to get out of share.
You can just click the share, where the share screen button is. You can just click it again.
Hang on, I've gone back to the camera somehow, which I didn't want to do. I may have to just resign from the meeting.
I think I can grab it from you because I'm the host, actually.
Okay, well, you can grab that back. That's just my favorite thing to look at in Tycho if we get there.
Yeah.
Thanks.
Can you zoom in on it any bit?
No. That's that area right there. That's where Jim is talking about. Should be about right there on that shot.
It doesn't work if the seeing is bad, but if it's steady like it was about 8:30 or 9, you could actually make out all those little mountains perfectly well. But I couldn't.
Yeah.
Older.
You know, I find that sometimes, like right before sunset.
Mm-hmm.
Especially when the moon's at around this phase, you can actually see a lot better, more detail than you can when it's dark like this.
Yeah, it's in the transition when the heat from the Earth is sort of balanced, and then as the night gets on, that's what's happening now. It's much cooler outside, and it's gone crazy. Much harder to see.
Oh wait, someone asked me the question: why is it called Mare Imbrium? It's actually with an I. It's okay. So there was this guy named, was it Mario Riccoli or Riccoli? He's the guy who actually named most of these the structures on the moon, and Mare Imbrium it's just the sea of rain. That's what it means. He just kind of arbitrarily named that, but it's noted that I believe it was the Syrians actually had named it something similar to that, thousands of years before. So some of the other cultures had actually named structures on the moon, but this guy Riccoli was able to. He basically, in I think it was 1689, was kind of grabbed the notoriety for naming most of the structures on the moon that we know of, the big ones anyway. Let me see if I've got all the questions answered. Yep, that's pretty much it.
Hey, Doug.
Uh-huh.
I don't know if you want to. I sent a link in the chat to a video that I posted. Again, it's of an almost full moon, with the Terminator. It's at the very, very edge, but it's literally just on the same telescope, a 4-inch refractor. No tracking, and all I'm doing is I'm using the slow motion knobs to kind of guide where the moon is drifting.
Oh, sure. Hold on a second.
And that little fringe is because it's not a corrected telescope, right? It's your AR.
Yes. Yeah. And you can. Yeah. It's a good example of color aberration. It's almost like this purple luminescence.
There we go. Can you guys see that?
Yeah, it might go, if you go into full screen mode, it might be easier. It's down towards the speaker. Yeah.
Oh, there it is.
Or if you do it again, I think it'll. I don't like Facebook for that reason.
That was the link that you sent me.
Yeah. No, it is. It's just there's a. I don't know why. I guess that's there. You go.
Yeah. Oh yeah. Yeah, that's excellent.
And again, this is an iPhone, just taking video. So.
Oh, did you get the little control, that the piece that was it? Who brought that to the club a few months ago? Actually, this has been a year ago. It was.
Yeah, it was a Celestron. It's called the NEXYZ.
Yeah.
Yeah, that's all I used on this.
Oh, that's cool. That's very nice. And you just clamp that to your eyepiece, and you just
clamp it right. Yeah.
Oh yeah.
And it's pretty rock solid.
Yeah. Yeah, that's very nice.
There's and then I think at another point, I actually then used the iPhone's zoom feature to get even a little
pinch
closer.
It out.
Yeah. So I kept the eyepiece the same, and you can almost see it's like that one crater in towards the very bottom. It's in the shadows, and it almost looks like it's got this canal running out of it.
Oh yeah, I see
like
that.
A valley. I mean, it was the most amazing thing. And to be able to see, the peaks of mountains in the, where the crater floor is still in shadow, and then, the peaks are just barely being sunlit.
Did you have to do any manual settings on your iPhone?
Nope. I just clicked.
Automatic. Okay.
I just clicked and went. And here you can see that purplish haze around the edge.
Yeah.
That's what they call chromatic aberration. So that's where all the different wavelengths of light are not being refracted to a common point, and gives it that edge. But yeah. So what's possible even with just iPhone astronomy? I think that's probably it on that one.
Good deal. Thanks. Yeah, that's good.
All right, that's cool. It's coming in there. Just give it a minute.
Yeah. But I think this perfectly highlights the, looking at objects near the terminator are just so much more interesting than looking at something that's just bathed in light on the face of the moon.
This is such bright light. Do you ever put filters? I always hear people putting filters to get better.
So I would say for visual, absolutely. It'll give you. I mean, if you tried looking through like Doug's 10-inch, it'll give you a headache. It's that bright.
Yeah, that's why the gain is clamped down so much tonight, because if you just adjust it just slightly to the left or right, it'll really blow it out quite a bit. So I'm going to try to boost it just a tad.
Yeah, I mean, I've seen people use, I guess, either rotating polarized filters or neutral density filters.
Yeah, the rotating polarized works real well if you do in visual, because you can put one on the bottom of the diagonal and one on the bottom of the lens. You just turn the lens to dim it down.
I will tell you a story once I get to the actual crater. Yeah, it's right here. Just give me one more minute here. 1 second.
Would you use a polarizing filter on a camera like this?
I could.
No.
Okay.
No, but mainly they use them for visual.
Yeah.
Because with a C8 or a C or a 10 like this, you would get a headache. It's way too bright. Even my little AR-127, Rob, I had to put a moon filter on because it was hurting me to look through.
Yeah. It's the thing is you have to take it off, and it's a lot easier just to go ahead and just adjust the gain on something. I will tell you, this is actually, I suppose this would be more confessions of an evil astronomer, but I guess it was actually last year, Mike. Do you remember when we were over at the eco station over there at Prairie Ridge? Well, anyway, about a year ago, we were having an astronomy session.
Sorry, I was on mute.
That's okay. About a year ago, we were on at Prairie Ridge for an observing session, and these three craters, Ptolemaeus, Alphonsus, I don't remember what the third one is, but these that you see right here in a line, well, they just happen to be kind of like right on the terminator, so it was kind of interesting. It actually moves over the night. If you actually sit there and watch this over time, over just a few hours, the terminator will move. Well, anyway, what was happening is actually they filled up. They were black by the end of the night, and someone was asking me, well, why are they black like that? And I said, well, that's because that's Trump's oil depot, and he's going to build a pipeline from Earth to the moon to get oil. And they're like, really? So you have to be careful what you tell people on when you're observing.
Yeah.
But yeah.
Especially people that you meet at the ones we do at the art museum. You got to watch out for those people.
Yeah.
Is that where the flat earthers go?
Right, Paul, you got to watch out for those guys.
That's our most mellow.
That's where I met Paul.
Is that where the flat earthers go?
Yeah. Oh.
I don't know.
Doug, you're not too far off that middle crater with the black spots in it.
Yeah.
Yeah, there.
Right.
We were at a lecture up at Wild Acres, and there was a specialist that talked about those, and he said that those little dark spots were punched, they think, maybe by small meteors, and there was a little bit of some sort of, I guess, lava underneath the surface that just punched through and made these little circles. And he said, this was like 15 years ago probably, he said that they were about the consistency of motor oil when they flowed out.
Oh, no, really?
Wow.
Yeah, so there's a little bit of oil in your story there that you could go with.
Let me bring these.
That's why Elon Musk is building those big starships. So they're really tankers to bring the stuff back.
Well, thanks a lot, guys. I'm gonna leave the chat now.
All right, guys.
Alrighty.
All right,
Have a good one.
Yeah, you know what? It's interesting though that actually in nebular clouds, you actually do find petrochemicals in nebular clouds. So it's not just made from fossil. I think it's incorrectly called fossil fuel. It really is. It does. You do find hydrocarbons in nebular clouds. So there's a lot more going on in a supernova explosion or or even in a nova that I don't think that we yet fully understand. But
well, I mean, just look at the moon, Saturn's moon Titan. I mean, and you've got all those gases. It's quote unquote fossil fuel heaven.
Now that is a pretty exotic place. I got to say that is pretty amazing.
Mm-hmm.
I'll share this slide real quick here, because if you kind of look at the morphology of moons and planets in our solar system, there's Titan right there, the one you're just talking about.
Mm-hmm.
You know that. I mean, if you think about it, I mean, it's got like, you know, its oceans and seas are liquid ethane. You know, that's pretty amazing. And the rocks and mountains are actually like it's ice, but it's like this really exotic ice, like ice 5 or ice 7. It's not. It's not what you would. I think what do we?
It's not H2O.
It's not H2O. It's actually it's a different crystalline structure than regular ice. I think what we have is what, ice 3. Is that what it is? I think. So, but anyway, yeah. It's. I mean, it's so exotic that you actually could have maybe a life based on maybe silicon or some other molecule besides, I mean, some other atom versus, you know, carbon like ours is, you know. So it's kind of interesting. But here's one of the interesting things. If you kind of look at the moon is almost the same size as Io. And just slightly larger than Europa. So if you ever wanted to know, well, what would those moons look like if they were near Earth? Now, of course, you have to, with Io, you have to kind of take the pizza analogy, you know, and just say, just put a pizza over the moon. That's probably what Io would look like in our orbit. But you know, definitely the moon and Europa, I mean, have kind of similar qualities. The other interesting thing is that Mercury and the moon, you know, the moon is only about 29% smaller than Mercury, and it's only about 30% larger than Pluto. So, you know, these, you know, are relatively similar in size when you're looking at night. You could almost imagine, you know, what those that you know, those sizes by just looking at our moon. Just.
But Pluto is what, another about 40 AU?
Oh yeah.
Away versus the moon is like
250,000, 248,000 miles. I mean, something like that on average. Yeah.
Speaking of the moons, and then I'm going to probably sign off. I'm going to try and share something if I can.
Yeah, sure.
On the December equinox. I don't know how I can it's weird. I don't know why when I go to share on my iPad, I go to screen and then it wants to record my screen. So I don't know why that's.
I'm recording the session, so.
Oh, maybe that's it. Okay, so
maybe that's it.
I'm going to share my screen and I'll say fine. You know, I'm okay with recording. 3, 2, 1. All right. So now nothing's happening. No, I can't do anything. Am I sharing anything at all?
No. I stopped share too.
Yeah. So I just wanted to point out that on the 21st of December of this year, that both Jupiter and Saturn are going to be within, let me do a quick calculation here. They're going to be within, I can't get that to go, 6 minutes and 14 seconds of each other.
Really?
In terms of yes. It will be right about 5:30. That it's a Monday night, 5:30. It will be about 17 degrees above the horizon. But you know, you should be able to get, you know, Jupiter and the 4 Galilean moons plus Saturn and everything within even a modest, you know, field of view camera.
Well, that would be great. That'd be cool.
I think it's an awesome photo opportunity.
Yeah, sure.
So I might just post that to the club.
Is that going to be in the 17 degrees above the horizon in the west?
In the southwest, yeah.
Southwest. Oh.
Yeah. So
I'm going to have to get some dynamite for those trees.
Yep.
My neighbor's not going to like that.
Or we figured out a good place a good session or someplace to go.
We might. Well, hopefully, hopefully we'll, you never know where we'll be at with this particular situation. But
I can think of one place called Cool Breeze.
Yes. Although it'll be cool there.
Oh yeah. Are you talking about the place where you guys? You talking about the place where you guys go for the astrophotography?
Yeah, the ECVAR, the astronomy video.
Oh yeah, I would say that's going to be mighty chilly.
What's the dew? What is the dew like
up there?
Yeah.
You know what? I have never. We haven't been to that, but it's not bad.
No, it's not as bad as Staunton River has been.
Oh yeah. No, there have been nights at Staunton River where it feels like it's been. I mean, you couldn't get any more water on your equipment.
You can literally see
without it actually raining.
Yeah, you can see it.
Yeah,
it's a haze, right? Last time it was brutal.
Haze, nothing. You can hang a bucket off the bottom of your scope and collect water. I mean,
that's the time I actually got in my scope, right? I had to clean my scope.
Yeah, because I remember I shorted out one of my hand controllers.
Oh, really?
Yeah. So.
Hey, before you go, I'm showing a slide here. This is basically on the left of the slide is the drawing that was made by the Apollo 17 astronauts. This was the guy who was in the command module as he was going over the moon. He was describing these rays that he was seeing. You can only see rays like this if you have an atmosphere. You've got to have something to refract the light. And so he was describing this, and he's giving some fairly detailed descriptions. And they basically poo-pooed what he had to say. But then after LRO got around and they started actually measuring the moon's content, they realized that, wait, it does have this rarefied atmosphere. It's pretty rare. I mean, in terms of rarefied, it's like it's only like a few atoms per inch, but still, give it over miles and everything, it accumulates. But it was kind of an interesting thing. But anyway, well, I mean, I pretty much don't have anything else to share. I'll hang on as long as other people want to hang on, but it's pretty much pretty much gone well over time. It's already 11, so. We hope you all enjoyed tonight's Moon Zoom. If you'd like to learn more about astronomy, check out our club website at www.raleighastro.org. Follow us on Facebook, Twitter, or check out our YouTube page, which contains lots of instructional videos that are free to watch. I'm JPL Solar System Ambassador and Raleigh Astronomy Club co-chair, Doug Lively, wishing you all a good night and clear skies.